Okay, welcome everyone. So again, thanks for coming. This is the online statistics webinar, and this is the very first webinar where we're actually going to do statistics. We had the orientation webinar last night, but that was just to show you what the course was about. This is actually going to be doing statistics. So just to note, if you have any questions, you can pop in the chat box and I will read it. So if someone says, how long do you think this is going to be? Usually an hour and a half to an hour and 45 minutes is your typical amount of time. Sometimes it depends on how many questions there are, but we'll see how it goes. So that's typically what it is. It's never more than 2 hours, and it's just about never more than an hour, less than an hour. So in between an hour and 2 hours, but usually an hour and 40 minutes-ish, it might be the average. And standard deviation might be about 10 minutes because this is a stats class and we're going to learn what that means in today, actually. So I figure I should say it. Let me tell you the plan of what we're going to be doing today. We will, as always, I'll always start with any questions you have, and not just start with questions, but throughout the whole webinar. If you have questions, please ask, and then I'll answer it. That's the whole point of the webinar, is so that you can get immediate questions answered during the looking at the materials. I'm also going to be introducing Kelly Greiner from the Student Accessibility Services in a minute, but I just want to go over what the plan is, and then you'll get to talk. I'll be talking about sampling techniques. That actually, in the real world, is the most difficult part of statistics. It's not the most difficult part of this class, but to get an unbiased sample is very difficult when you're talking about people, especially. So I'll talk about that, and I'll talk about some different strategies that people use so that you can conduct a study and use it to get an idea of what the population is about without having too much bias. Then, I know this is the name of the class, statistics, but we'll talk about all the different statistics, or at least some of the different statistics that we're going to be doing in this class. Some you already know, like average, we'll call it the mean. You know the maximum, you know the minimum. The standard deviation will be a biggie. First quartile, third quartile, z-score. There's a whole lot of statistics that we'll talk about. Then we'll talk about, well, how, if you're making a presentation, how are you going to make it so that people can see the results? So those are charts, things like a histogram, or a box plot, or a stem and leaf chart, or a pie chart. Some of these you've seen, some of these you may not have, but you will by the end of the week. Then we'll talk about the z-score, and that's a measure of how unusual something is, and we'll talk about what that's all about. And then I'll also look at different types of variables. So depending on what the survey is, a variable is going to be different, and we'll talk about that. So that is the plan for this webinar. And again, please ask any questions you have. And here's a question. So someone asked, do you recommend that we review the material before the lectures? This is all about what works for you. So if it works for you and you tend to learn better if you look at it before the lecture and then watch the lecture, then do it. If you like to watch the lecture to get introduced to it and then see all the little details by reading it, you know, and watching the full videos, then do it that way. So this really depends on you. And you should do, in this case, whatever works best for you. Make sure that you have everything done for the week in time. So Thursday, it has to, by Thursday, you have to have your discussion initial post down. And by Sunday, everything has to be done. So that's the one thing that has to be done that way. But the timing at which you watch things or read things, that you should do whatever works best for you. And you can try both and see. When I was a student, I'd read the entire textbook before the course even started, because that was just me, and I'm a little weird. Most people wouldn't do that. But again, whatever works for you, you do what works for you so that you can succeed. So hopefully that answers your question, even though I didn't really answer it. But good question, good question. I want to introduce Kelly Greiner. She is the director of the student accessibility services, and she's going to talk a little bit about the what services that they have, how you can go about getting assessed, and why it's a really good idea if you even have a suspicion that you might need it, it's still worth it. So Kelly, can you introduce yourself and talk about it?
Thanks, Larry. My name is Kelly Greiner. Like Larry said, I'm the Director of Student Accessibility Services. So what does that mean? We do disability services and accommodations for students with disabilities. We serve a really wide range of students, so you might be eligible for our services if you have a mental health condition like anxiety or obsessive compulsive disorder or bipolar disorder. You might be eligible for our services if you have diabetes or a learning disability. We do services like extra test time. We can help you get audio textbooks if you're in a class that has a lot of reading. We have a program right now where if you physically write your math out, you can take a picture of it and it helps you type it up so that you don't have to go searching for symbols on your computer. That could help students with learning disabilities. And then we also help students who are not yet identified as having a disability. So if you just like generally struggle in school or there's a specific subject that you struggle with, we provide a learning disability assessment and that can make you eligible for our services. And if you're local, we do those here on our campus. If you're not local, you can go to your local California Community College and get assessed there to get the services. Definitely, I think for an online class, the most helpful thing we have is that extra test time. So if you get through your first quiz or you get through your first test and you realize that you didn't have enough time to finish all of the questions, you definitely should come and see us. Larry, do you want to open up a Google tab for me real quick?
When you
Just a
say Google
plain
tab, you mean
Google.
just like that?
Yep.
Okay.
And then type into your Google search LTCC space SAS and hit enter. We're that first link there. So it's just as easy as Google LTCC SAS. And if you've never used our office before, you would click new students and you fill out a new student application because you're new to the program. And once you fill out that new student application, we're going to come after you. We're going to call you. We're going to email you. We're going to help you get the services. And that's really it. So yeah, you can find us on the website. I'm sure that Larry has our contact information and Canvas for you guys.
Yep, on the
And just if
syllabus.
you have any questions, come my way.
Any questions at all about the services? Again, they do a great job and they'll help you out. So definitely, you know, if you even suspect that you might need it, go and get the help. Okay.
All right, you guys have a good class. Thanks for having me, Larry.
All right. Thank you. Thank you for coming. And now let's do some statistics. So as I mentioned, unlike last night, today we're actually doing statistics. So today is chapters 1 and 2. And chapters 1 and 2 are, they're a little different than some of the rest. There's a lot of language. It's mostly language. And that's a lot of vocabulary and techniques and stuff. Very little that, you know, of like analyzing full conclusions of things. It's more of looking at some things and looking at, and statistics, actually, we'll see that too. So I like to bring in, and this is something you'll see in pretty much every webinar, just about, I like to bring in a kind of a modern, you know, today's stuff. I always go to the news and see what's up in the news. And I pop in something that I read, and what I read was an article, and the title of the article was that most Americans, let me make it a little bigger, say criminalizing abortion is wrong. Okay. By the way, one of the things I will not do in this class is tell you how you should think politically. What I will do is tell you how to look at an article and say, did they do their statistics right? That I can tell you. but I will not tell you whether you should think abortion's right or wrong. I won't tell you that, but I will tell you, how do you read an article and how do you understand whether they applied statistics in the proper way to come up with results that are reliable? So one thing is, most Americans say criminalizing abortion is wrong. Do they really know this? This was by a Marist poll. Do they know that most of all Americans say criminalizing abortion is wrong? What do you think? Yes or no? You pop in the chat box. Thoughts? Okay, I'm seeing kind of both. And seeing some yeses and nos. So let me ask you this, okay? If they know about most Americans, that means they asked all Americans. How do I know personally? I know for sure they did not ask all Americans. How do I know? And my guess is you know also, but I might be wrong, but my guess is you also know for sure. Any thoughts? Okay, they didn't ask me. Okay, and by the way, I've been teaching this for, decades. I never had a student say I was one of the people they surveyed. Maybe it'll happen today, but I'm not seeing you. Did any of you, were you the one that took the survey? But probably not. No, no. Could they have asked everybody? No way. There's no time. There's 340 million or so Americans in, here. There's no way. There's no way you can ask everyone. You just can't do it. You can't. So it's not true that they know for sure that most Americans say criminalizing abortion is wrong. What they can do, and this is what they did, is they took a poll of 1,305 national adults. And I want to let you know, that's 1,305 national adults out of, if we're looking at adults, out of, 270 or so million adults, national adults. Not even close to the proximity of how many national adults there are. So does that mean they know nothing? It doesn't. It doesn't. Because what we're going to learn in this course is how we can look at a survey where they only asked 1,305 and see how reliable that survey might be. And later, and not today, but later in this course, we're going to be able to say that 1,305 is actually a large enough sample to have good data and to have something that's pretty reliable. Not absolutely for certain, but certain enough that they can stake the reputation on it. And that's really what statistics is all about, is you can't ask everybody because it's too much work, okay? By the time they're done, I don't know, there won't be America anymore. It'll take, centuries to finish, and it will be something else. Who knows? The point is that you can't ask everyone. There'll be new people by the time they're done with even 100 million people. Then there's another 100 million people born, because it's going to take a century. So the question is, you can't do it. But what you can do is you can do a survey, and then based on that survey, you can say that we have reliable results. We're not 100% certain, but we're pretty certain that it's true. All right, so one of the problems, and this is a big issue, is that they're going to ask 1,305 national adults. It takes a lot of work to do that, by the way. And to do a survey, you're going to have to find people to answer your survey question. And you want those people to be representative of national adults when it comes to whether you think criminalizing abortion is wrong or right. Does that make sense? You want to make sure that you don't have bias. Okay. My favorite example is, let's suppose we wanted to find out the average height of national adults. Okay, then let's suppose I just took the first class I taught. Okay, those were national adults, by the way. It was at UCLA. Okay, it was the first class I taught. And I used that. Do you think that'd be good? What do you think? To find out what the, national average height is? Okay, let me just tell you, if I use that, I would think that the average height of national adults is 7 feet tall. Okay, you're probably in shock. Any guess on why? I don't see you guessing. The first class I taught, yeah, it was the UCLA basketball team. I wasn't told in advance, by the way. They just walked in one at a time. The last guy was 7'7". And so that would be a completely biased study. Do you see that? To go and ask basketball players what their height is and say, there's their national height. That would be as biased as it could possibly get. Okay. So one of the hard parts is, how do you reduce the bias? How do you make it so that how do you make it so if you're going to survey 1,305 national adults, that those are representative of all national adults, that you haven't like pushed one side or the other, in this case, when it comes to how people think about criminalizing abortion being right or wrong. Any questions on that idea? Okay, so there are lots of choices, and let me show you what they did. This is that Marist poll, and I did look at what they wrote about the poll. And what this says is the survey. Let me make it a little bigger so you can see it better. The survey of 1,305 adults was conducted March 25th through March 28th, 2024. I try to give you things that are, current. Okay, and it's a pretty new survey. It's one of the newest surveys I can find. Okay, by the Marist Poll sponsored in partnership with NPR and PBS NewsHour. Adults 18 years age and older residing in the United States were contacted through multiple mode design. Why, by the way, why did they ask only adults? Any guesses? There's 2 reasons, by the way. Any thoughts? Register to vote, that's possible. But then they'd ask for registered to vote adults. Adults that are registered to vote. Not everyone's registered to vote. I am, by the way. Okay. So let me tell you. Okay, one is they want to do a survey to find out about national adults, but more important, here's a bigger issue, and this is going to be really important for this class, by the way. It is against the law to survey children without doing all kinds of paperwork. So for you're going to do for project 1, you're going to have to conduct a survey. You are not allowed to survey children. Got it? You are not allowed to survey children because I don't want to get arrested and you don't want to get arrested. Adults is pretty not a problem, but children, there's all kinds of laws. Do not survey children. Got it? And they're smart enough that they don't want to get sued either. So that's one biggie, is it's legally a big problem to survey children. So don't even think about it. Okay. There are ways of making it happen, and you can't even imagine the paperwork you have to go through just to make surveys happen with children. So we're not going there. This is elementary stats. So they did adults. Okay. Then they did by phone, using live interviews, by text, or online. Okay. So one of the things, why didn't they just use the phone? Any thoughts? Why didn't they just call a bunch of people? 1,305, call the 1,305 people and ask them, do you think criminalizing abortion is wrong? What's wrong with doing that? There's something really wrong with it. Yeah, not everyone answers. In fact, My guess is all of you, I might be wrong, but usually it's true, all of you have been called by someone doing a survey and you didn't answer. And I have, by the way, many times. It's a big problem because people who tend to answer their phone tend to be a different type of person. They have a certain social whatever, and they might be more or less likely to say criminalizing abortion is wrong. So if you only do phone, there's all kinds of issues with people responding or not, and they call that voluntary response bias because you get to choose whether you want to answer or not. And those people who choose to answer are probably a different type of person when it comes to thinking about abortion being wrong or not, or criminalizing abortion being wrong or not. So that would be biased, and it would be voluntary response bias. Any questions on that? So they also did text messages, hoping that that might help. And they also did online, so emailing people probably is my guess, and or maybe with a website. And that helps some. It's not perfect, by the way. It's very hard to be perfect. Okay, but it does help. It makes a difference. Okay, and by the way, my first job, one of my first jobs for a company was I actually was that person who called people and conducted surveys. Okay, so that was one of my first jobs. Any guess on how old I was? Let's see if you can put in the chat box. What's your guess on how old I was when I did this for Carroll Davis Market Research Company? And I called people. Okay, no one ever guesses, by the way. By the way, I'm really old now. Things were different in the old days. I was 11. Nowadays, that company would be arrested. But things were different in the old days, just to let you know. So I actually had that experience. I was not a statistician. I was an 11-year-old kid. And it just was a job because I had my grandmother worked there. They had me. So I know it like from firsthand as a child doing it. And most people don't even answer, just let you know, even those days before the internet. So you could do by text, you do by online, you do your best. Okay, there's going to be some bias. Okay, then if you read a little bit more, I'm going to skip a bit. So surveys are available in English or Spanish that try to reduce that bias of language. Most people in America either speak English or Spanish. There are some that don't speak either, but that'll get you most of them. And then let's do some more because this is really important. So online samples were selected to ensure that each region was represented in proportion to its adult population. So that is really important. One thing is, if you know anything about America, if you ask this question in, say, Oklahoma versus asking the question in California, do you think that criminalizing abortion is wrong? Do you think you would get the same answers in Oklahoma versus California? What do y'all think? Think you're going to have the same proportion of people saying that it's okay to criminalize abortion? People in California versus people in Oklahoma? Absolutely not. So what they did is they looked at the regions, geographical regions. They didn't say in this paragraph, at least, what they mean by region. It could be state, it could be whatever. And then they made sure that every region was proportionately represented. And that's a step-by-step process. The first step, let's say we did it by state. What you would do is you say, what's the population of adult Americans in California? Divide that by the population of adult Americans in the United States. Multiply that by 1,305, and round that to the nearest whole number. And that'll give you the sample size, how many people you need to survey in California. You do that from each state, and you make sure you survey that number of people. And what that does is it completely takes away any bias by state. Any questions on that idea? And that's called stratified sampling, which I'll show you in a bit. have that formal definition, but that's how you do it. Stratified sampling is the most common way of sampling to prevent bias. So one bias you might think of, again, would be region. Because if you know anything about America, then you know that different regions in America are very different when it comes to supporting criminalizing abortion or being against criminalizing abortion. Okay, Oklahoma and California are totally different. And if you don't know that, you know it now, by the way. You could look it up and it's obvious. Okay, just a note. So then you would say, well, what else might make a bias? And let's read some more. So they looked at age, gender, income, race, and they looked at religion. And basically what they did is they did exactly the same thing. Is they said for each gender, whether that would be male, female, or other, let's call it, then they said what percentage are male, what percentage are female, what percentage are other. Multiply that percent by the 1,305, and that's how many of each of the genders they would have to survey. They did it for income with income group brackets, they did it for race, they did it for region and age with brackets. Any questions on the idea of this sampling technique? And by doing that, what they have done is they have made sure that there is no regional, age, gender, income, race bias. The factors aren't isolated, so it must complicate things a lot. Actually, in terms of the real world, it's not that hard. That sounds hard, but it's actually not that bad. It's just, the hardest, the biggest actually challenge on this, it means your survey is going to have to be longer because you're going to have to ask the person, how old are you? What's your gender? What's your income? What's your race? And what's your region? It makes the survey longer. Okay, it turns out the statistics is not much harder at all, but the survey is longer and people often don't want to do long surveys. So that's the bigger issue in terms of the real world. Okay, in our class, I'm gonna have you pick on just one. You get to choose which one, because I figure if you can know how to do one, you should know how to do all the rest of them too. Doesn't matter. Okay, any questions on that? But good comment, because again, this is the first day of learning elementary statistics, so I don't expect you to know any statistics. So again, you don't know what's hard and what's easy, or what's needed. So that's one of the techniques, and this is what they use. This is used the most when it comes to surveying people, by the way. And that is doing that. Okay, and that is, let me type that out. That's called stratified sampling. So stratified sampling means that you determine the strata, such as age, gender, income, etc. Then research the percent of each group from the population. Okay, in the old days, that was actually hard. Now it's usually 5 seconds on the internet and you can find it. So that's the research is easier. Then multiply the percents by the sample size to determine the quotas. So how many do you need to survey in each of the group? That's what a quota means. Then do the survey. Making sure that each quota is exactly established. You keep surveying until you've gotten that number of each group. Don't survey any more than that number or any fewer than that number. And that's your survey. And then you put it all in one column of data and you find the statistics. And that's any questions on stratified sampling. It's the most important and most common of all. Okay. There's actually one other that's common that's not good. And I'll talk about that in a little bit. Okay, I want to mention something, that there are types of variables. One is a qualitative variable, and the other is a quantitative variable. A qualitative variable means that the answer to the survey question is a word. Things like, what is your favorite color? Put in your chat box, what's your favorite color? Okay, I'm hoping none of this is too personal, right? But it doesn't matter, I'm not reading it. Okay, notice you all had a word answer. You didn't say 73.5. Okay, so that would be a qualitative survey question or a qualitative variable. Is that clear? Okay, on the other hand, quantitative means that you have a number answer. So that might be something like, how old are you? Maybe you can put that in the chat box. And by the way, you're allowed to lie in this class for that kind of thing. But you probably don't need to. You can say how old you really are. Okay, and notice everyone answered with a number. So the variable of age is quantitative. Is that clear? The variable of color, unless you're a physicist, by the way, I'm not going to get into that, is qualitative. Okay, sample size, I want to let you know that we always use the letter N for sample size. N stands for number, by the way. So N was 1305. Okay. Any questions on sample size idea? There are a lot of different types of surveying. One is called convenience sampling. And that is exactly what it sounds like. Any guess on what it means to say, I did a convenience sample? Let's say bad. Bad isn't quite the word. Doesn't mean that you're an evil person. Yeah, it's unreliable. So if it's convenience sampling, it's unreliable. What convenience sampling means, it means you just survey whatever's easiest, walk around, ask your friends, hey, post on social media and let your friends answer, that kind of thing. That's total convenience sampling. Okay? You should never use convenience sampling when you worry that your data might not be representative of the population. If you want your data to be representative of the population, don't use convenience sampling. Okay, so if people are going to die because what you said might have been wrong, then don't even think about using convenience sampling because you're killing people. Got it? Okay. We talked about voluntary response bias. Then there are a lot of others too. Okay, just a note, again, there's a lot of language. This is today's language day. So one thing is there's a statistic and there's a parameter. A statistic comes from the sample, a parameter comes from the population, from the entire population. Are there any times when you can actually get a parameter and know it exactly? The answer is sometimes. The answer is sometimes. Let's suppose you wanted to find the average number of calories that people who live in your household consume today. Could you ask everyone in your household? Yeah, no problem. Okay, there might be 3 of you. You just ask them. Do you see that? That would be an example where you can do a parameter. Any questions on that? There are also times you can do a parameter, such as elections. And not before the election, but after the election. If you want to find out the percentage of people who voted for Biden 3.5 years ago, you can do that because that's a parameter. We have all of the data of voters who voted for Biden. Does that make sense? If you want to find out the percentage of people who will be voting for Biden in November of 2024, you're not going to be able to get a parameter, because if you want to do it to, this month, because you don't know, you can't get everyone. Do you see that? So those would be two cases, one you can, one you can't. Any questions on that? All right, here's a tough one that everyone has trouble with. Random sampling. Do you know what that means, to randomly sample? You've all heard it, right? Let me ask you something. I'm going to ask you to put in the chat box. I want you to pick a random number. How about between 3 and 5? And put in the chat box. Pick a random number between 3 and 5. 2 shouldn't be it, by the way. 2 is not between 3 and 5. Okay, here's the thing. Did you really pick a random number? You didn't. And do we have any psychology majors here? Turns out psychologically, we do not have the ability to pick random numbers out of our head. Okay, so maybe you've learned this one, you psychology major. We don't have that ability. Yeah, it's more psychology than sociology, because it's a brain thing. We don't have the ability to pick random numbers by just picking one off the top of our head. We just can't do it. And they've done a lot of studies on that in psychology, actually, to see if people can pick random numbers or random whatevers. And the answer is no. But that doesn't mean you can't get a random number. How do you get a random number then? So if I really wanted you to pick a random number between 3 and 5, what would you do? Any guesses? So you had to do it, and you had to make sure it was random. I'm not seeing any answers. Let me show you. You go to the calculator. Computers are really good. You do hat, but that's old style. Now people use a computer. There's two ways of doing it. One is clicking on random number generator. But the low is 3. The high is 5. There we go. Got one. Got another one. Got another one. Computers are very good at picking random numbers, by the way. And it gives you random numbers. I coded this, by the way. Not by using my brain, by the way, of like picking a random number. It's all, true randomness. So you could do the hat, but people use this. There's another way too, and maybe you could try it right now. Anyone have a smartphone with you right now? Ask your smartphone, maybe we'll go from 1 to 100. Say, hey, Siri, pick a random number from 1 to 100. It'll give you one. Bet you it will. They all do it. Unless you have a really old phone. If you go 1 and 100. 28. Okay. Your phone will do it too, by the way. Random numbers are one that the phone can actually do without any problem. Okay. I've never seen a phone that doesn't do one for newer smartphones. Any questions on that idea? Okay, so random numbers, what you want to do, if you want to get a random group from a population, there's a step-by-step process. What you have to do is you have to first order the entire population. And sometimes that's impossible. Sometimes it's possible. Then you use a computer to pick n random numbers from 1 to that population size. And then you survey the selected individuals. Okay, the hardest part of that, there's 2 hard parts. One is ordering all the people. It's actually against the law to try and go to the police and get the name of every person in your city. They're not allowed to tell you. There's privacy issues. So good luck getting a list of everyone. There are some populations you can where it won't be like a whole city, but it might be your class, for example. You can look at your class and you can give them each a number, and then you can pick a couple people. So if I asked you, you have to have, a random group of 3 in your project, I could have asked that. I decided not to. You could actually do that by literally letting a computer pick the people. Does that make sense? not that hard to order all the people in a class of 30 or 60 if there's 2 sections. Okay. And that's what we do. And then we have random sampling. I want to let you know that if you think that you did it random in some other way other than using a computer with an ordered list, you're wrong. It's so impossible. So don't beware of ever using the word random in anything you do in this class. Because other than I didn't use a random sample, I used stratified sampling. That's okay. Because random sampling is really hard. Okay, any questions on that? Okay, stratified sampling I already talked about. The next one is cluster sampling. Okay, and let me explain what that is. We divide the population into clusters that represent the population, and then sample every item in each cluster. So let me give you an example of this. And I know put in the chat box that you're in Tahoe. You live in Tahoe? Yes or no? So yes, I live in Tahoe. No, I don't live in Tahoe. I'm just interested. This is in the chat box is all. It's not going to go on the line or anything. I don't have anyone living in Tahoe. Okay. I hope you've heard of Tahoe. It's not just about a college, by the way. Okay. So let me tell you, I'm going to use Tahoe examples sometimes because that's where I am. Let's suppose you worked for the Forest Service and you wanted to find the average height of pine trees in the Sierra Nevada mountains. Okay. And hopefully you've been to the Sierra Nevada mountains. It's not just Tahoe too, it's a huge area. It's one giant pine forest. Okay, there's no way you can get every pine tree because there might even be 1 billion pine trees. I mean, there's a huge number of pine trees in Sierra Nevadas. Okay. And the other problem is if you wanted to say stratified sample or whatever, you could do that, but that's a bit hard. Getting to places in the Sierra Nevadas is really hard. A lot of it is wilderness area. You're not even allowed to take a helicopter there. Okay, so good luck. So what you can do though is you can get, let's say, a map of the Sierra Nevadas, and you can look at maybe by acre. Okay, you can take your map, you can divide by acres, using some geographical kind of sense. And then what you could do is you can say, well, let's pick some acres in the higher elevation. Let's pick some acres that are kind of closer to water. Let's pick some acres that are maybe drier. Okay, so that it kind of represents the population of Sierra Nevada. By the way, do we have any biotype people or environmental science? Because that would be like an environmental science kind of thing, or Forest Service or firefighting. That's all important in those fields to find out how tall the trees are. Anyone in that? Not seeing anyone jumping in. Maybe we do. Maybe some are watching this as a YouTube video. Okay. But that's the kind of thing they would want to do. So then what they would do is they might pick like 7 different acres. And then and it might take a lot of hiking to get to them, by the way. They go to each of those acres, so 7 acres, and they'd measure the height of every pine tree in each of the 7 acres, which would take some time, but it would be at least doable. And that would be called cluster sampling, because they've taken 7 clusters that are representative, and they did every single tree in each of the clusters. Another example that happens a lot is college students. Let's say you wanted to survey, 1,000 college students at community colleges. What do you think the natural clusters would be? It wouldn't be acres anymore. What do you think the clusters would be for community colleges? Remember, you have to survey every person in each of the clusters chosen. That's it. That's a hint. Any idea of what a natural cluster would be? Supposed to be pretty obvious, by the way. I don't see you jumping in. All right, I tell you. Classes. So what you would do is if you wanted, let's say you wanted to find out, I don't know how many units students are taking at community colleges, then you can go to, say, a bunch of classes that are representative of community colleges. So you might go to, you know, a rural college, you might go to 3 or 4, you might go to like a 5 or 6, you know, more colleges in the city. And then you'd make sure that the classes are representative. So a math class, an art class, maybe a PE class, you know, different classes that are representative, and then survey everybody in each of those, you know, few classes that you looked at. And that would be cluster sampling. Okay, and you've reduced some of the bias, not perfect. And since you've surveyed everyone, there is no volunteer response bias because you're making everyone do it. And by the way, instructors can usually do that. If I tell you you have to answer my survey, you usually will. Okay, so that's typically done for students. Let me give you a next one, and that's systematic sampling. So I'm going to give you an example of one that I helped out a former student who went into business after he got his degree, and he made towels for hotels, and he wanted to compare how good his towels were to towels made in China. His towels were in California. So we wanted to make sure that we had a random sample of his towels. Okay, and he had different places that were manufactured and different types of towels and stuff like that. So what we did is we took every like 200th towel that came off of the assembly line, and he tested those towels to see how good those towels were. That's called systematic sampling. That works when you can order the whole list and then pick every like 100th one, in general, every nth item of the population. That's also done with online surveys sometimes. Is that what'll happen is that you'll code the website so that every, you know, 1,000th person that comes and clicks on your website gets a message saying, we'll give you $10 if you answer our survey. Can you do it for us, please? That would be systematic sampling. Any questions on that idea? And it takes away a lot of bias, which is good. Convenience sampling I already talked about. The other biggie, and this is important, anyone going to be doing any kind of medical career like nursing or any kind of medicine? Any of you going to be doing medical degrees, medical work? Usually I get a group. Not seeing you all jump in, but my guess is there'll be some people in the class that are going to do medical stuff. So this is one where you want to see if medicine is working. So let me give you the most that everyone knows about. You don't know the details necessarily, but you might, but you may not. I do because I read about it before I got my shot. Okay, what is the most important medical procedure that happened in the last 5 years where they had a new kind of medicine and they had to test to find out if that medicine worked? It should be obvious. You've been asleep for 5 years if you don't know. Yeah, COVID vaccine. Okay, that's obvious. So let me tell you how they did that. Okay, what they did is they got volunteers. Okay, one thing is for you know reasons of ethics, you can't force people to be part of a trial run to see if this vaccine is going to work and not kill you and that kind of thing. So what happened is they got 40,000 volunteers. They actually got a lot of volunteers. And they randomized and they randomly selected, I'm not exactly sure if it was 20,000, but let's just say it was, they randomly selected, so they put all their names in a computer. They had the computer randomly select 20,000 of those people. And those 20,000 people got the vaccine. And the other 20,000 people got a shot were told they got the vaccine and they got nothing. And then they waited some months later to see of each of those two groups did the group that got the vaccine, were they less likely to get COVID? By the way, do you think they were less likely to get COVID when they did the test? That was Pfizer actually did the first test, but Moderna also did one. And the answer is yes. Yes, otherwise the FDA, Federal Drug Administration, they would not have approved it. And so the FDA did the test and they made sure that it worked before they put it out to billions of people. Because you don't want to, send it out to billions of people if it doesn't work, or even worse, if it hurts you, and doesn't work. So they made sure it worked before they opened it up to everyone. And that's called a randomized control study. Okay. And it's especially used in medicine. Okay. I was actually part of one of those experiments. It was a long time ago, way before COVID. I was at UC San Diego. There was a article in the newspaper saying, if you have the runs, run to the medical center and be part of our experiment for free. And as you might guess, I had a bad day that day in terms of having the runs. And unfortunately, I was one of the placebo groups. I didn't get better. The next day, I let them know I was still feeling horrible. They said sorry, and then they gave me real medicine. And then I got better. But so I was one of those, but I needed the money because I was one of those poor students. I ran and got money. And unfortunately, still stayed sick for an extra day. So I actually got it personally. So that's called a randomized control study. Very important. Okay, because it allows you to know that it's really the only way with statistics that you can show cause and effect. Okay, because that's the only reason why it could be different, is that cause and effect. Any questions on any of these processes, any of these methods for sampling? It's much easier to say them than it is to do it, by the way. Conducting research takes a lot of work. So it's much easier in class than it is in reality. Just let you know that. Okay, so let's talk about statistics. I know it's the name of the class, but here it is. There are a lot of statistics. So a statistic, this is very important. It's the name of the class, so it must be important. It's a number that is calculated from the sample data. You take a sample, and then from that sample, you look at numbers that come from it. There's some that you already know. The word mean, in our class, I want you to use the word mean and not the word average. Average tends to have more than one meaning. That's why you don't want to use it. So please use the word mean. Anytime you want to think about average, use the word mean. Got it? So mean means add them up and divide by the total. That you probably learned in elementary school. So mean is very important because that's kind of the most important statistic for quantitative data. You can't add a bunch of yeses and nos or a bunch of blues and reds, but you can add a bunch of numbers. So we're talking about, especially in these, when you have quantitative data. Have you heard the word median before? I know you've all heard it, but it might have been so many years, you may not remember it. And remember what it is? He says an idea. Yeah, the median is the middle. Yeah, it turns out it's either the middle or the average of the two middles if there's an even number of numbers. Does that make sense? Because there is no middle if there's an even number of numbers. If there's four numbers, there's no middle number. Okay, if they're all different. So you take the average of the two. You don't have to worry about the calculation. You have to understand what they're used for. So let me ask you something. Let's look at home prices. Let's go in California because I can see that most of you are not in Tahoe. Why would you, who would care about the median home price? What's it going to tell you? Maybe I'll even use Tahoe because Tahoe makes a really good example for that, even if you don't know Tahoe well, but you could pretend it's California. Because it does work, but Tahoe works even better. Anyone know about the median? Why would you care about the median? Okay, it tells you the middle of all the home prices. So that gives you more of a general idea of what your kind of normal person would be like in terms of, normal home would be like in terms of price. Okay. I want to let you know, I'm going to give you Tahoe as the example, but it does work in California, but Tahoe really works. You've all heard of Tahoe probably. And that is, there's the mean also, and that is different. So if you want to kind of find out what the kind of the general person is in Tahoe, the median is much more important. On the other hand, there's the mean. Turns out we have almost no houses that are anywhere near the mean in Lake Tahoe. And the reason for that is if you've been to Tahoe, we have this beautiful lake. And there's a group of houses that are like right on that lake with a beachfront property. Same thing in California, where you can be right on the beach. And what do you think it costs to have a beachfront home? Any guess in Tahoe? You have one of the really nice beachfront homes in Tahoe. How much do you think that would cost? Okay. Like $30 million. It's one of the most expensive places in America, actually, when it comes to the high level places. So it'd be like $30 million. It is so much more than everywhere else. On the other hand, I'm a teacher. Do you think I could afford $30 million home? Not even close. I have a regular house, okay? But I'm not poor. I'm a teacher. I have a regular salary. So I'm more like the median. Do you see that? If you take the mean, you got these $30 million houses, then you have these regular houses, and that $30 million house is going to skew the mean to the high side, and the mean might be like $2 million, even though there's very few houses for $2 million. So if you want kind of a general normal house to think about in Tahoe, the mean is terrible as a number. The mean is much better. Is that clear? On the other hand, if you were the mayor of Lake Tahoe and you cared about how much money is coming in through house taxes, the mean is much more important than the median, because that $30 million house is going to be taxed in a huge amount and bring a huge amount of money towards the city in the taxes. And you don't want to ignore that $30 million house. So then the mean would be important. So it depends on what you're looking at, whether the mean or median is more important, even though they're both about houses. Any questions on that idea? Okay, so it's important that you understand what they're for and what they tell you. Okay, so the median is that middle part. It cuts it in half, right? It turns out that the mean and median are important, but the problem is the standard deviation is super important too. And what that tells you is how spread out the data is. So are all the houses really similar, or are they all over the place when it comes to prices? And if they're all over the place when it comes to prices, then the standard deviation will tell you how much all over the place they are. If they're all close, the standard deviation will be really close to zero. So if the standard deviation is really large, then the house prices are all over the place. If the standard deviation is small, then the house prices are real close to each other. Any questions on that idea? So the standard deviation is kind of an average distance from the mean that the values are. Any questions on that idea? And why did I put it in giant font? Any guess? There's a reason. It wasn't an accident. Why did I put standard deviation in giant font? No, it's not the secret word. Yeah, it's important. Let me just read it. Standard deviation. You need to know that for this entire course. Okay, so it is the most important new statistic in this whole class. So make sure you totally understand it. Okay. Now comes some somewhat important ones, nothing like standard deviation. So the median cuts it in half. Instead of cutting it in half, what if you wanted to cut it in quarters? Then, and statisticians do that, then we're going to have what's called the first quartile, and we're going to have the third quartile, Q1 for first quartile, Q3 for third quartile. Q1 is kind of the value at which a quarter of them are below you. Q3 is the value at which 3/4 are below you. Okay, I will tell you, this completely drives me crazy. It's the one thing that makes me more angry than anything in all of statistics. Want to hear the terrible thing? The Statistics Board of America has not decided on an actual formula for these. And depending on what calculator you use, you get slightly different numbers. Okay, they're not that different, but there is no perfect formula. And if you use a spreadsheet, you get a different answer than if you use a calculator. Isn't that terrible? And I actually wrote something to them and they said, sorry, there's too much argument. We can't do anything about it. So I want you to especially understand the idea of the first quartile and the third quartile. Okay, that's more important than the calculation. Got it? Okay, the interquartile range, so also called IQR, is the third quartile minus the first quartile. It's the range from the first quartile to the third quartile. So it's that middle 50%. And very important, say, in business or in teaching, if you want, you've probably heard that you should teach to the middle 50% of the class. That means you're teaching to the interquartile range. Or in business, if you want to advertise to that middle 50%, then that's the interquartile range. Any questions on that idea? Okay, then the next one is called the Z-score. Everyone uses the letter Z, and there's a formula. This is actually the first official formula for this class. And it's not that hard, but what is hard are the letters. And these letters you must know. We're going to be using them in the entire rest of this class. Okay? So Z equals X minus, anyone know what this letter is right here? How to say this letter? Here's a hint. When I go home, my cat is going to greet me with this letter. Aha, we do have somebody. And she's going to say, mew, 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 mew. She really means give me food. That's what my cat always says, and pet me more. But this letter is read mew, and it's a Greek letter, and it means the population mean. This bottom letter here is also a Greek letter. And don't get mad at me. Don't shoot the messenger. This is what everyone in the whole world uses. And that is sigma. Anyone speak Greek? Anyone from Greece? I never had a student that's fluent in Greece because they grew up in Greece, but maybe someday. It's very rare, I think. No, I guess not. Okay. And by the way, I'm not either. I know the letters from math, but that's about it. And X is going to be the given value. So X minus mu is how far away the given value is, whether above or below, from the population mean. Then divide that by the standard deviation, and that gives you the Z-score. And the Z-score gives you an idea of how rare or unusual the value X is. If Z is close to 0, then the Z-score is small, and we're going to say this is a pretty usual thing to get. If Z is higher Okay. Then like say higher than 2, for example, then we're going to say it's unusually high. If it's lower than -2, we're going to say it's unusually low. And there are some words to talk about what it means, a word to say being very unusual. What is that word on something being very high or very low in an unusual manner? You probably all heard the word before. You may not have thought about it too much. Yeah, outlier. So we'll call it an outlier. And in our class, our definition of outlier means greater than 2 or less than -2. Got it? An extreme outlier will be greater than 3 or less than -3 for the z-score. Got it? Okay. So the question was, are you going to learn about z-score tables? All right, you vaguely remember it from high school. I sure hope you're old, really old, because if you're not really old, then your high school teacher didn't do things right because they should use a calculator or a computer and not a table. Okay, those are the old days. Okay, yeah, I used tables when I was a kid. So I'm hoping that you're older. Oh, you're young. Okay, all right. You don't have to tell your teacher. I just dished them, but but yeah, no, people don't use tables anymore. They use calculators and computers. Just let you know that. And I'll show you how to do that in a bit. Yeah, no, tables are that's old fashioned. No one does it anymore. And I want you to do things the way people do things now. Just let you know that. So no, we're not going to use tables in this class. That's not going to happen. All right, so I want you to put in the chat box, and the first person to do it is going to get information about each other. I want you to state a quantitative information you're interested in about each other. So a survey question is quantitative. First person to put it in, we're going to ask that one. See if you can give me a quantitative survey question. Okay, so I'm going to turn it into a survey question that's a little easier to understand instead of just hours of sleep. How many hours of sleep did you get last night? That way it's more specific. When you're doing a project, for example, you want to make sure that your survey question is very clear. And put that in the chat box. Wow, some of you are not sleeping enough. 2? Hopefully you slept in the daytime. Okay. All right, so what I'm going to do, I think I'm going to do it this way. I'm going to go here, and I'm going to pretend that you've already made a copy of the spreadsheet. And I'm going to kind of highlight these numbers. I'm going to hit the backspace, and that clears them out. Then I'm going to pop in these numbers that you put in. So we have 5, 5, 5, 5, 6, 7. So you just put in 5, 5, 6, 7. Then we have 2, 7, 7, 5. And another 5. So I just want to show you with this spreadsheet, and this is what you're going to have to use your project for. By the way, there's a reason why I'm going to make you use a spreadsheet for the project. And that is there are some universities out there that if you don't have a statistics class that used a spreadsheet, they don't accept it for transfer. And then you're going to have to retake statistics. So for me personally, my number one obligation is to ensure that this class works for transfer to every university, okay, for elementary stats. So this way that there's some universities and they'll say good. Okay, and often I have to email and say that, show the syllabus or whatever and tell them what you had to do. And then they say, great. And then it works for transfer. When I first taught, a lot of times they said, no, that never happens anymore because I've adjusted the course in this way, for example, to make sure that it transfers. So this is a spreadsheet. And I created this, it's called Google Sheets. And this gives you a whole bunch of things. The minimum was 2. somebody who's probably very tired right now. You only slept 2 hours. Okay, the mean was 5.44. So again, it's important to be able to understand what these numbers mean. We've talked about them already. Standard deviation. Okay, this gives a lot more decimals than you ever need. But you can always round to say 1.6. And that's the standard deviation. That's pretty wide, actually. Okay. The median was 5. Okay. Maximum was 7. Nobody's had a long night's sleep. Okay. They recommend 8. Okay. Q3 was 7. And if Q3 is 7, that means at least 1/4 of everyone who answered said 7. Because if 25% is at or below 7, but no one said higher than 7, then 25% are at 7 in this case. Do you see how to read that? Please stop me if you don't understand something. Who remembers what n represents? Kind of the easiest statistic of all, but it's an important one. It's the number of, yeah, it's not the population, it's a sample size. Sample size, good, good. It's the sample size. So 9 were surveyed. I'll get to this SNL in a bit. That's next. Q1 was 5. So that means 25%. The bottom quarter is kind of 5 or below-ish. Okay. We're not going to do this confidence interval stuff today. That's going to happen in about 3 or 4 weeks, but it's in the spreadsheet because it's part of statistics. See where it says z-score? See where it says x value 5, change this? If you want to find the z-score for a number, you put the number in. So let's decide, was this value of 2 an outlier? So here's what we can do. We can take that 5, make it a 2. I hit enter, and we have negative 2.17 about. Was sleeping 2 hours an outlier? What do you think? Remember, we have a definition of outlier. Yeah, the answer is yes, because it's less than negative 2. And that was our definition. If it's less than negative 2 or greater than 2, it's an outlier. So that means, given the fact that z is negative 2.167, or 166, sorry, that means we have an outlier here. Do you see that? Any questions on that idea? Okay. There's a lot of other stuff that we don't do. I'm not going to go over everything. There's a lot of statistics that other people from other colleges ask me, and I'll put it in, but I'll put it at the bottom so you don't have to see it. Okay. How many of you seen what a histogram is in your past life, your past experience? Hopefully you've seen histograms before. Okay, this is an example of a histogram. And a histogram is a type of bar chart at which the first thing, the variable has to be quantitative, never qualitative. Second is each bar has to have the same width. And the height of the bar is a frequency. So we can say that, there were 4 people that said between 4 and 5.3. There was 1 person that said between 2 and 3.1. Do you see how that works? Let me show you. Stem and leaf is not very important. I'm going to do that with maybe a different example because it doesn't work with single digits. And I want to let you know, you cannot do stem and leaf with single digits. And that's just SNL. SNL is stem and leaf. What I can do is I can do a box plot. So let me show you how that works. If I go to stats and I click on box plot, what this will do is it will show what's called the 5-point summary in a picture. The 5-point summary is the maximum, the third quartile, the median, the first quartile, and the minimum. In this case, one thing, we had a small sample size, and there were a lot of people who said the same answer. So in this case, the the maximum and the third quartile were the same number, 7. And also the median and the first quartile were the same number, 5. Okay, so this is a little weird example. I'll give you one where it might look a little better. And the minimum was 2. The box is that middle 50%. Any questions on that? So it's a nice way of showing the data. I do want to let you know there's a problem with using this if you're doing a presentation to the general public. What's the problem? If you just did a presentation, you were doing it to an audience of a couple hundred people, just from general people. Yeah, most people have no idea what this means. They haven't had a stats class. They won't know what this is. So it doesn't work well with general public, but it works great for research stuff where the people reading this are educated. Okay. It turns out those of you who are pretty young might have seen box plots in high school. That's actually kind of a new thing. So high school students now are all getting box plots. If not, then your teacher didn't do the right thing, because in California at least, is that's actually one of the standard things that you're supposed to learn is a box plot. When I was in high school, I didn't learn what a box plot was because it wasn't one of the standards. Okay. Any questions on the idea of a box plot? All right, let's do a different one. Let us do, how about how old you are? So I'm gonna drop all these numbers. Put in the chat box, how old are you? And again, you're allowed to lie, but make it reasonable. Don't say you're 950 years old. 20, 20, 25, 24. 19. 20, 53, 20. 26. Okay, maybe I'll give myself my own too. I am 57. 57.76. Most of you probably don't think about your age that way, but yeah, I'm a math guy. Okay. So one of the nice things we can do is you can show this kind of a combination of the histogram and all the numbers without losing anything. And the way you do that is you do what's called a stem and leaf. If you have a 2-digit number like that, we're going to let this 10 power be 1. If you had a 3-digit, you might let the 10 power be a 2 instead of a 1, by the way. Okay, it gets a little messy. And I'm going to go stats, and I'm going to go stem and leaf. And what this shows is we haven't lost any of the data. Do you see that? We have everybody's answer, but you have to know how to read it. So we have one person who was 19 years old. We have 4 people who are 20 years old. This 2 is a 10-digit. These zeros are the 1-digit answers. We have a 24-year-old, a 25-year-old, a 26-year-old, a 53-year-old, and a 57-year-old. Do you see how to read this? And this gives you a way of showing it pictorially without losing any data values. And this is called a stem and leaf diagram. Any questions on that? Okay. You could also see it with a histogram, but now we've lost the values. You can't tell me how many people are exactly 20 years old after looking at this histogram. Do you see that? Whereas you can say there are exactly 4 people who are 20 years old from this histogram. You can understand the mode. The mode is the highest frequency value is 20 years old. Do you see that? Because we have a 20, a 20, a 20, and a 20. There were 4 of them. Any questions on that? I just want to also note that from this histogram, we can see there's a high bar, and then it gets lower as we look at it. Do you see that? We call that skewed right. If it starts high and then goes low to the right, it's skewed right. If it's a mirror reflection, we call it skewed left. If it's high in the middle and then it goes down on left and right, then it's just symmetric. I'm not sure what you mean by can also be a trend. One thing, our sample size is tiny, so you shouldn't trust much of anything. That's just a note, but we can only do what we can when it comes to sample size because that's all we've got here. But the word's important, skewed left and skewed right. We have symmetric if it was left and right, if it was a mirror image from the middle, left and right, then we call it symmetric. If it is bell-shaped, in this class, we're not going to use the word bell-shaped. The word we use is normal. We're going to have chapters on that. So right now, I just want you to know the idea, bell-shaped is normal. Got it? So that's the word we're going to use for bell-shaped is normal. Any questions on that? Okay. If there were two high bars and everything else was kind of lower, then we call it bimodal. By the word, bi. You've heard the word bi before. What does bi mean? It's used as a prefix for a lot of different things. Two, yeah, like a bicycle means there's two wheels, right? Right? Bisexual means that you have two sexes you like. Do you see? Bimodal means there's two modes. So that's why we use the word bimodal. Two high points. Okay? Unimodal, what do you think that means? What's a unicycle? Yeah, just one mode. Unicycle means there's one wheel. So unimodal means there'd be one peak. So this, what we're looking at here, either way you look at it, is unimodal, right? There's one mode and everything is small compared to that. Do you see how that works? If everything was exactly flat and all the bars were exactly the same height, then we call it uniform. And when you think about wearing a uniform, you wear a uniform so everyone could look the same. That's the point of a uniform, by the way. I don't know if you ever thought about it, but that's the reason. It's all the same. So every bar has the same height, then we call it a uniform distribution. Got it? So a lot of different words for distributions, and you need to know today's vocabulary day. I don't know if you've gotten that down, but that's what we're doing today. A lot of words. Okay, and there are a lot of words in this class, by the way. Right? Have we done any algebra? Right? Other than maybe the z-score formula. That's about it. There's not a lot of algebra, but there's a lot of language. And get used to it. It's what this class is. Has a lot of language, a lot of vocabulary. Any questions on this idea? Okay, let us continue on. Okay. Let's look at some applications of standard deviation. Okay, let's look at the stock market. And I'm going to talk about this a lot because I care about it. Any guess on why I care about it? There's a good reason. Money's good, but why do I personally care? Okay, I care because I make money on it. I invest in the stock market and I've done very well with it because I know what I'm doing. I've lost money too, but I win a lot more than I lose because I use statistics. Okay, if you have a high standard deviation, what does that tell you about that stock in the stock market? And some of you might, there's a word for it actually that people use in business. Anyone know what it is? If you have a high standard deviation, what does that tell you about the stock? If the stock's price has a high standard deviation, what does that mean about the stock? Good, good, yeah. It means you have a volatile stock. Goes up and down and up and down and up and down. Okay. Okay. And by the way, I'll let you know that could be good or it could be bad. Depends what you're doing. If you're a day trader, it's actually really good. If you're one that panics every time you lose money, then that's horrible. Do you see that? So if you have a high standard deviation, it might be good, it might be bad, depending on what your goals are and what your mentality is. Is that clear? If you have a low standard deviation, then that means that you have stock that isn't changing much. It might be going up and up and up and up slowly, but it's not going up and down and up and down and up and down and up and down. And that's a different kind of investment. Okay, and there's stock that does that. That's more likely to do that. Let me give you another example. Okay, let's suppose that my goal is to have most of my students pass the class. I would love to see almost everyone pass my class. Sound good? Could see that being my goal? That's my goal. Your goal might be to get an A. I don't know. Might be just to pass. I have no idea. I want you to pass. Okay? And if you remember from the syllabus, 70% or higher is a pass. Okay. If the average percent is 74%, am I satisfied? What do you think? Am I satisfied if the average percent in our class was 75%? Okay, so here's the deal. I haven't told you enough information. You have no idea. Okay, let me give you some more information and then you'll be able to say. Now let me give you some more. Let's suppose the standard deviation was 0.02% and the average was 74%. Am I satisfied? Okay, and the answer is yes, because pretty much everyone passed. Because remember, being 2 standard deviations away is an outlier. That's 0.04% difference. Okay, so even a 73.6% would be an outlier, and that's still a pass. Do you see that? So if the standard deviation was 0.02%, then I'm very satisfied. Everyone passed the class. Do you see that? Just about. There could be maybe one person out of 1,000 or something that didn't pass, but probably not even that. Any questions on that idea? Okay, what if the standard deviation was 20%? Am I satisfied? Okay, then definitely not, because there's a whole big group of people that are on the low side and the high side. There's all those people in like the 50s and the 40s. And then there's all these people that are in the 90s, but almost nobody near 74%. It's like all pass and all A's and F's. And that's about it if I have a giant standard deviation. Do you see how to read those numbers? Any questions on that idea? Okay, so here's something really important. And this is called the empirical rule. Also, some people call it the rule of thumb, but we're going to call it the empirical rule. And that is if the shape of the distribution is normal, remember that was bell-shaped, then there is a 68% chance of being within 1 standard deviation of the mean. Okay, so if you're normal or even like close to normal, close to bell-shaped, then there's a very high chance of being within 1 standard deviation of the mean, or in other words, having a z-score being between -1 and 1. Because the z-score is the number of standard deviations from the mean. There's a 95% chance of being within 2 standard deviations of the mean. And that's why people typically use 2 as the outlier. Because 95% is kind of that's most people, a vast majority. Do you see that? And then, let me erase that. There's a 99.7% chance of being within 3 standard deviations of the mean. Okay, that's just about everyone. Do you see that? 99.7% of all people, okay, or of all things, whatever you're looking at, have a z-score between -3 and 3. Any questions on the empirical rule? Okay, This only works if the distribution is approximately normal. Are all distributions approximately normal? Any guesses? Any thoughts? Okay, the answer is definitely no. So for example, let's suppose you looked at the height of adults and you look at the distribution of heights in inches, let's say. Why do you think that would not be normal? Why would the distribution of heights not be approximately normal? There's a reason, actually, a very specific reason. And we're talking about adults. Ideas? Many factors, but there's one specific main one. Let's see, I'll jump it in. Should I tell you? Biological male and biological female. There's that 5'4", and there's that 5'10", and you have it's a bimodal distribution. Can you imagine that? And it's not normal. Normal is not bimodal. Normal is unimodal. Has one high point and goes down from there in both directions. Does that make sense? So that would be an example that is not approximately normal. And there's a lot. There are a lot. Any questions at all on this idea? We've talked about all of these charts, so I don't need to talk about them again. Let me talk about the next main thing. Talked about all of these. Let me give you another example. Okay, I like this. I know none of you said you're in medicine, sorry, but I usually get a bunch. I'm surprised. I usually get a lot of people that want to be nurses or whatever like that, and they're at college for that. So we'll see. There might be a lot of you that are watching this on YouTube, but that's typical. Okay, suppose that you are in the hospital and you're taking care of an infant that was just born. Got it? And the z-score, okay, the z-score in weight was negative 3.7. What will happen to the child? See if you can tell me in the chat box. What do you think is going to happen in that hospital? Are you just going to ignore it? The z-score is negative 3.7 in terms of the weight of the child that was just born. Okay. Okay. Something's wrong with the child. It's not just something. Yeah, it's extremely dangerous. That child is going to go directly into ICU. That child needs a doctor. That is a extreme outlier on the low side of weight. And that is a very underweight child. Child probably will not live. Okay. And by the way, my brother knows about this more than just about anybody. Anyone guess what he does for a living? Yeah, but what kind of doctor? Yeah, he delivers babies. Not a pediatrician. He is a baby deliverer. That's his job. It's not just a doctor, but he delivers babies for a living. Okay, so he knows more than anybody. So I can't tell you what the average weight is or what the standard deviation is. I don't know. But if someone told me the z-score, I know immediately there's an issue. Do you see? Even if you don't know anything else about the data, all you need to know is the z-score. What if the infant had a z-score of 3.1? Then describe. What do you think that tells you? Any thoughts? I tried to make it somewhat obvious. I mean, you don't have to be a doctor. Yeah, they're not just overweight, it's extremely overweight, and that mother almost certainly had to have a C-section because the baby was way, way big. And if the baby's way, way big, it doesn't just come out of the uterus. They need to cut it out. And that would be a C-section. Do you see how that works? So by looking at the statistics, then you can decide what to do as a doctor or a nurse or whatever it might be. Any questions on that idea? Okay, a third infant was born. The Z-score of that infant was negative 0.19. What can you say? So again, the first one, that baby goes right to ICU. The second one, that woman is like in tears and crying and screaming. And the third one, you hand the baby over to the mother and say, wonderful baby, no problems.